would be one that you guys wanted to see. Okay, so 6 is, as we talked about before you guys were going to do this, is that you're going to need to use complete in the square. But besides that, as long as everyone understands the process of this, then you guys are in good shape. Now, remember, the first step that we have to do is we have to make sure this is set equal to 0. And we want the 0 to be on the right side. It's just easier to read the greater than or less than that. So there obviously is not 0. So we're going to move this to the other side. It's a negative, so we're going to make it positive. So it's going to be x over x minus 2 plus 1 over x plus 3 is greater than 0. All right, so that's the first step. Make sure it's equal to 0. Second step, make sure we have one fraction. Obviously, we do not have one fraction. We want to make it one fraction. So our common denominator is going to be x minus 2 and x plus 3. So we are going to multiply x by, we already had the x minus 2, so we need to multiply the top by x plus 3. It's an awful 3, but it is. Plus, here the x plus 3, we have to multiply the top, which is just 1, by x minus 2. So up top, I get x squared plus x minus 2, which is x squared. That's a 3. I knew I was going to make that mistake. Right? Did that say 3? Yeah, sorry. So that's going to be 3x plus x is 4x minus 2. So x squared plus 4x minus 2, when I distribute that and combine like terms, over x minus 2, x plus 3. So we now have one fraction. So now we need to find our critical values. All right, well, the bottom's easy. We get 2 and negative 3. Now for the top, we normally like, okay, let's just factor that and we'll be able to solve. The problem is that you can't factor x squared plus 4x minus 2. There's no two numbers when multiply to give me 2, subtract to give me 4. So we have to either use the quadratic formula or we have to use completing the square. All right, I'm going to do completing the square. I'm just going to put it over here, give myself a little more room. So x squared plus 4x plus blank, because I'm going to move the 2 to the other side. All right, I move the negative 2 to the other side. Remember, we take half of the coefficient of x, which is 2. That's going to be squared. I then square 2, and that's what I add to both sides, which equals 6. Then take the square root. So x plus 2 equals plus or minus the square root of 6, which is negative 2 plus or minus the square root of 6. All right. So those are going to be our two other critical values. So we have negative 2 plus or minus the square root of 6. All right. Now, problem is, and that's the only issue, is you need to figure out roughly what they are as decimals so you can know where to place them on a number line. All right. So if you need to put that into the calculator, I believe negative 2 minus root 6 is negative 4.45. Negative 2 plus root 6 is like positive 0.495, something like that. All right, 0.45 we can call it. So if we're making a number line, what's the smallest number between all of those? Well, it's negative 4.45, but I'm going to write it as negative 2 minus root 6, because that's what I'm going to include in my answer. But I know that's roughly negative 4.45. So then what comes next? Negative 3. Then 0.44 comes next. So that's going to be negative 2 plus root 6. And then the largest number is 2. Right? So now, once you've done that, it's the exact same thing where you pick a number. So this is negative 4.4. Let's pick negative 5. If I plug in negative 5 to the top here, negative 5 squared is 25. Negative 5 plus 4 is negative 20. Minus 2, that gives me positive 3. It's a positive number, okay? So I really need to know it's positive. -5 minus 2 is a negative. -5 plus 3 is a negative, but a negative times a negative is a positive. A positive over a positive is a positive, right? If we then picked another number, -4, if you pick -4 in here, so the same thing happens at the bottom, you get a positive, but up here you get 16 minus 16 minus 2, that is a negative. A negative or positive is a negative. And just to save time, you can go back and plug all these in. This is what happens. You get a positive, negative, positive, negative, positive. All right. So once you get that, it's greater than 0. All right. So that means I'm looking for all the positives. So here, here, and here. All right. So now the only thing you have to do is interval notation. Negative infinity to -2 minus √6. So in the worksheet, it says to use the actual real part of it, not the decimal. That's what it means. Put -2 minus √6, not -4.45, not the decimal. Okay. Union -3 to -2 plus √6. Union 2 to infinity. Now, I used all parentheses because it was just a greater than. There was no equal to, so you didn't have to worry about it. All right. If this was a greater than or equal to, the 2 and -3 would have gotten brackets. All right. That would have gotten brackets. Now, don't stress too much about the completing the square part. As long as you're understanding the process of how to go through and do each step and do the interval testing, you'll be fine. Any other ones you guys would like to see? Okay. I do have a copy of the answer key. I will post that for you guys on the classroom just so you can just take a look just in case. But yeah, so I'll do that for you. All right. So what we're going to do today is we are going to. Here we go. Okay. So we're going to solve these using a calculator. All right. So same type of problems, but now we're just going to use a calc. All right. So we have 3 over x plus 1, 3 over x plus 1 less than 4. So the same thing that we did before is we want to set it equal to 0. Okay. So we want to set this equal to 0. So I'm just going to subtract the 4, obviously, over. And we get 3 over x plus 1 minus 4 is less than 0. Okay. Now, normally we would have to combine this into one fraction. We don't need to do that because we're just going to plug this into the calculator and we are going to graph that. That's what we are going to graph. Okay. So let me bring up my calculator here. All right. And gonna, oops, open up a new thing. All right, I'm gonna add a graph. All right, so this is where we're gonna put our function in, which is in this case 3 over x plus 1. And then I believe it was minus 4. Okay. And this is what our graph looks like. I'm going to zoom out just one time, just to give us a little better view of this. Okay. So this makes sense. This looks like one of our rational graphs that we graphed before break. Now, the key thing that you have to be aware of, all right, is what is not drawn here, but you can tell there is one by looking at the graph. What's happening at, looks like it's -1. There's a what there? Yeah, there's a vertical asymptote. Okay, there's a vertical asymptote. So you should be aware that there is a vertical asymptote at -1 because what makes this equal to 0, right? -1. So there's a vertical asymptote at -1. This is important. Oops. The reason this is important, because you know how we had our critical values before? On a graph, all right, the critical values on our graph in the calculator are asymptotes, and they're going to be the zeros. All right, those are the numbers that are your critical values. That before, when you do it by hand, you have to calculate it by setting the top equal to 0. But if you set the top equal to 0, that means y is 0. That's the x-intercepts. That's the zeros. If you set the bottom equal to 0, that's the asymptotes. So looking at the graph, you need to know where the asymptotes are, and you need to know where the zeros are, because that's where the critical values are, and that's what we're going to use in our intervals. Okay, so if we drew a rough sketch of what this looks like, right? There's x equals -1, right? This is -1. You could also tell that there's a horizontal asymptote. We don't really care about the horizontal asymptote right now, all right? But there is one. But it looks like we have, it goes on here. And the other thing we need to find, obviously I said, was the zeros, all right? It looks like it only crosses one spot. So what we're going to do is, hopefully you guys remember, menu, 6 for analyze graph, 1 for 0. Put it to the left, put it to the right, and we get -0.25, comma 0. All right. So that's your other critical value. Asymptotes, zeros. There's only one asymptote. There's only one 0. All right. So I have a point here that's -0.25. The graph does this a little bit, right? And it does this, all right? Something like that. It doesn't have to be a perfect sketch. You don't even have to sketch it if you don't want to, okay? So once you have that, all right, normally we would do interval testing, right? Well, we don't have to do interval testing. We just have to look at the graph. Where I am looking for where it is less than 0. Less than 0 is below the x-axis. Greater than 0 is above the x-axis. So I am looking at the graph here and here. So when I do interval notation, your interval notation is either going to be something to do with negative infinity, positive infinity, or one of the critical values. My critical values are -1 and -0.25. All right. So the first part that is under the x is this. So this is negative infinity to what? Well, what's this dot? What's this asymptote? Oh, that's -1. Union. All right. The next part's here. Oh, that was -0.25 to infinity. And there's my answer. All right. I'm giving the intervals where the x values, where the y value is below the x axis. All right. What the equivalent of this is if I were to draw my number line, I would have had -1 and -0.25 on it, right? If we did it by hand, I would have done an interval testing, and I would have been like, oh, well, it was less than -1. Between -1 and -0.25, it was positive, and this was negative. But instead of having an interval test, I'm just looking on the graph. Oh, this is below, that's negative. Oh, there it's positive above, so it's positive. Here it's below, it's negative. All right, so that's how it relates, how we did it by hand. Now you're just looking at a calculator and a graph to be able to figure that out. Now, the reason I have all parentheses is because it was just a less than. All right. All right. Questions on that first one?
If it were greater than 0, would you just switch the vertical asymptote and the asymptote?
So if it was greater than 0, what's the only spot it's greater than 0? This spot here, right? Which is there. So that would have been from -1 to -0.25, and that's it. Okay. Other questions? Okay. All right, let's take a look at number 2. It Same thing, we're gonna have to subtract 5 first. All right, you're gonna subtract 5. Now, I think it's a good idea before you even graph it is to be like, okay, where is my vertical asymptotes gonna be? All right, because that's gonna be, important when you are looking at the graph. Because remember, on a calculator, the vertical asymptotes aren't drawn there for you. All right, so how do I know? I would look in the bottom, whatever the denominator, whatever makes the bottom equal to 0, which in this case is plus or minus 2, right? So when you graph 2x over x squared minus 4 minus 5, when you graph that, you should see 2 vertical asymptotes. So go ahead and, if you have a calculator, graph that. I'll bring mine up here in a second so I can graph mine. 2x over x squared minus 4. All right, let's see. Triple insert. I'm going to graph here, though. Calculator. Two x over x squared is 4 minus 5. All right, so hopefully you were able to get that graph up there. And you can see where you have vertical asymptotes at 2, right? You can see how, right, -2 and +2, all right? And there's like an S curve in the middle, all right? We've seen ones like this when we did it by hand, okay? So I know -2 and +2. They're very important pieces here, all right? The other important pieces that we need to find are the zeros. So that's what we use the calculator for. So menu 61. All right. And that first one is -1.81. And then we'll do it one more time because it looks like it crosses over here, obviously. I don't care where it crosses the y-axis. I just care where it crosses the x. And 2.21. All right. So our critical values for this problem are plus and minus 2, because those are the asymptotes, -1.81 and +2.21. Okay, so that's just to kind of draw what the rough graph of this looks like. So 1, 2, dot, 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 dot. 1, 2, 3. Okay. So what was it? Something like this. Like I said, you don't have to. I'm just doing it so we can refer to it. Don't have to keep going back and forth. All right. And I think the other one was something like that. Okay. That was 2.21, that point there. This point here was -1.81. Okay. All right. So remember, the important points you need are asymptotes and zeros. So everyone understand that. Those represent our critical values of what we did yesterday. So now we just have to look at where the graph, in this case, is greater than 0. So that is, where is it above the x-axis? Where is it above? So I look, it's above here, there, all right? Does everyone understand that's the 2 spots where it's above? Now you just have to figure out, well, what are the critical values that's between? So this one is between what? The dotted line, which is our asymptote, which is -2 to this 0, which is negative 1.81. This is no equals to, so they're both going to be parentheses, union this guy, which is positive 2 to 2.21. There is your answer. All right. Does everyone understand that? The answers that will go in your intervals will either be the asymptotes or the zeros. All right. All right. Let's do one more. You guys do that. And a nice thing about this one is you don't have to set it equal to 0. So 2 over x plus 3 squared minus 4 greater than or equal to 0. Put into the calculator. There's only going to be one vertical asymptote for this one. So make sure you remember the vertical asymptote, find the zeros, and then you're figuring out where it's greater than or equal to 0. Okay, so in your graph, hopefully you guys got this graph, all right? You can see by looking at it, there's an asymptote there at negative 3, which makes sense when you look at it. You had x plus 3 in the denominator. Negative 3 makes it 0. So negative 3 is going to be one of our things, and then we have to find the zeros. So just menu 61. What did I hit? Not the right thing. There we go. Oh my God, I'm going to lose my mind. Menu one more time. Third time's a charm. Let's see. Yeah, there we go. All right, negative 3.71. And then we'll do it one more time. Negative 2.29. All right, so negative 3.71 and negative 2.29. All right, so no way to remember those numbers, but it's okay. So we have our graph. We have at negative 3, we have something going on, right? That's the asymptote. And then, oops, but that's awful, but you guys get the idea. All right, so the key points here, we have negative 3. what was it? The zero is negative 3.71, and I think the other one negative 2.21. Going on a limb here. Don't know if that's right. 2.29, close enough. You guys get the idea. Yeah, that's a 9 anyway. There you go. That's a 9. All right. So we are looking where it's greater than or equal to 0. So it is greater than or equal to 0, that section and that section. Okay. Which means it's between each of these zeros and the asymptote and the asymptote and the zero. It's that little section in there, right? Where it's above. So this here, that point right there, that's negative 3.71. And it stops at the asymptote. Union, then it's at the asymptote to the other zero, which is negative 2.29. All right, what you have to be careful of, and I know the parentheses aren't right, so don't jump on me quite yet. All right, you gotta be careful because if you don't actually realize the asymptotes there, if you just look at the actual graph on the calculator, you might be like, oh, there's only one interval. It's from negative 3.71 to negative 2.29, right? But there's an asymptote in there that breaks it up. All right, imagine that if you were doing this on a number line and you're doing the critical values, negative 3 would be on there, and you might have plus plus next to each other, but you would then be easier to split up the interval that way, okay? Because it's an asymptote, you have to split it up. All right, now this is an equals to, all right? Which means we have brackets. However, the asymptote would make the bottom equal to 0, never going to have a bracket. So that is still going to be a parentheses. The ones that make the zeros, they are going to have the brackets. So that has a bracket, and that has a bracket. All right. So when you're doing it on a calculator, the asymptotes never get the bracket if it's the greater than or equal to. All right. In the doing by hand, it's what makes the bottom equal to 0, which in essence are the asymptotes. All right. Questions? All right. So what you guys are going to do, I already posted it on the classroom, is you're going to do 4 through 6. All right. These 4 right here using the calculator. And then tomorrow, we are just going to just review by hand and by calculator. And then Friday, right? Yes, I do see Friday. You're going to have a little mini assessment, 15, 20 points, 2 by hand, 2 by calculator. That's it. Okay. And obviously that will be on this marking period still, all right? Because marking period doesn't end until next week. And then next week, then Monday, well, Tuesday for you guys, when we're back in school, we will be starting the next unit. All right. Any questions? All right. Have a great day. Enjoy the weather, and I'll talk to you guys tomorrow.
Have a good day.
Thanks, guys. See ya. You too.
Thank you.
See ya.